How's it going? This is the tutorial for the coding task, machine learning classification of Twitter. Here's the instructions file. So if you download the project folder from Moodle and you save it to your machine and you unzip it, you should see this is the project folder name. And then inside of the project folder, you have a data folder, a scripts folder, and analysis. The data folder will have these two files, labeled data and unlabeled data, and the scripts will have two Jupyter Notebook files, pre-processed labeled tweets and train, test, and implement in SVM. The analysis file for now will be empty. So, so as I said here, the task is using machine learning classifiers. We're actually going to use SVM. So SVM classification of Twitter. And specifically, we're going to look at two data sets, the hate speech and offensive language data set, which is our labeled data. Here is the GitHub where I downloaded that data. This actually comes from a research paper by Davidson on hate speech and offensive language. So if you go here, you can find it. I think in the data file, I might have also included the URLs. So if you want to check out those references, here's some links for the labeled tweets, Davidson's hate speech and offensive language data sets. The second one we're going to look at is unlabeled tweets, Donald Trump's tweets from 2010 to 2021. Get this from Kaggle. Actually, this is from Kaggle too. I'll put the Kaggle link here. These are unlabeled. And then there's some other hate speech or offensive language data sets I encountered. I'll put a few more links here. We won't use those in this activity, but I'll just put those here for reference. So I want to show you these two data sets, the labeled tweets and the unlabeled tweets, just to see what they look like. So the labeled ones here, the original labels are 0 for hate speech, 1 for offensive, and 2 for neither. So you can see these in the data set, the class here. So 0 here is hate speech. So these tweets have been identified by a majority of evaluators as examples of hate speech. You can filter this if you want to see class 1. So class 1 is, these have been identified as offensive, but not the level of hate speech. And then you can look at 2, which have been classified as neither offensive nor hate speech. So what I want you to do, though, is kind of look over some of these, is to see kind of the subjectivity and how these are classified. And again, note that even the evaluators, in this case, count here is the number of people who evaluated each tweet. This is the number of people who identified it as hate speech, offensive, or neither. And then the class is like whichever one of these is the majority. Right? So in this case, 6 out of 9 said this was was neither offensive nor hate speech. So they classified it as 2. What I'm going to do in this with this analysis, I'm going to I'm going to transform the labels. So I'm going to group hate speech and offensive speech in as one. I'm going to call that hate speech or offensive speech. And then the neither category I'm going to take as kind of the null, right? So 0 in with my transform labels will be 0 will be neither offensive nor hate speech, and then 1 will be, offensive or hate speech. The reason I'm doing this is because the difference between hate speech and offensive speech is very subtle. It's very different. It's very subjective, I think, in some cases. Whereas the difference between offensive or hate speech and neither is a bit clearer, I think. So that's a bit of an easier classification test. So, and then we also have the Trump's tweets from 2010 to 2021. Those are in the unlabeled data file. So unlabeled data. So these are tweets from Trump. There's a date here. If you expand this, you can see. Oh, sorry, 2009. They each have an ID, whether it was retweeted, deleted, some metadata, whether it was flagged or not. F and T here mean false or true. So if the tweet was flagged, that would be a T. Some of these are T's. So, but here's the actual text of the tweet. You can see here I've added the class column, but I've just written it or filled it in as X because I don't know. These are not classified. Right? And you'll notice that there are about, how many of these? About 50,000 tweets. So Trump tweeted about 50,000 tweets from 2009 to over about a 12-year period from 2009 to 2021. So, okay, so the general idea of this task is going to be to use the hate speech label data, the hate speech and offensive language label data to train an SVM classifier, and then we're going to apply that classifier to Trump's unlabeled tweets and see, do we identify any of Trump's tweets as offensive or hate speech? And if, and then look at those results and see, do we really, how good of a job does the classifier do? And how hard is it to really classify something as offensive or hate speech? Okay, so there's several steps, analysis steps in this. So I just want to go over these before we jump into the actual code. First, I'm going to have you, I want you to examine like six different sets of features. So in our menu, in our pre-processing, sorry, let's go to scripts. When you pre-process tweets, right, as you'll remember from earlier tutorial, we can perform a number of pre-processing steps, like such as I'm going to go down to a menu here. Step 2, this pre-processing menu, right? We can remove stop words. We can make things lowercase. We can lematize. We can filter parts of speech, and we can also remove named entities or other types of other words. So what I want to do with this, with these first 2 steps, is I want to train 6 different SVMs. So the first one will be setting all flags true, right? So we have 5 flags here: stop words, lowercase, lemmatized, filter. So I want to set all of these true, right? And I'm going to run script 1 on here, not on the unlabeled data, but the labeled data. I'm going to run this script number 1, pre-process labeled tweets, on the labeled data 6 different times. The first time I'll run it to go down to the menu. So These are all my functions. Step 1 is the tokenization, so we'll just leave that alone. Step 2 in the pre-processing menu, right? You have menu choices. So first, once I want you to run script 1 on pre-process label tweets with all 5 flags true. So I'm going to do that right now. So you can see it's importing my libraries. It's going to import the label data. Here it's going to recode the classes. So you can see it's identified 5,891 tweets as neither offensive nor hate speech, and 18,892 tweets as either offensive or hate speech. And then here's my analysis path, all of my functions that I'm using to do this. I'm just going to skip over these functions. Okay, then I have tokenized the tweets. I used a custom delimiter here this time instead of the regular NLTK tokenizer because I didn't like what it did last time. So here now we're tokenizing white space. We're tokenizing anything commas followed by optional white space or periods followed by optional white space. So these are all what we're using to tokenize. So you can see here after we tokenize, customized tokenization completed. So we took things like this. If this is the original tweet, then here it's been tokenized, right? So into a list of tokens. So, okay, so now we're going to pre-process. So in here, I've already set these to true and I ran it. So, here's some extra parameters for stop words, n-grams. We're going to leave these all as they are. One thing here on the remove RE list. So this step here, remove RE flag. This RE means regular expressions. So I'm not going to classify or remove named entities in this pre-processing step, but I do want to remove a few things. I want to remove Twitter handles, which begin with the ampersand, and I also want to remove URLs because I think these are going to be unnecessarily like noise. So I'm removing anything with a Twitter handle or a URL. So that's what this step is doing right here, remove RE flag. Okay, and then I pre-process those. You can see this is actually still running. So we remove the stop words. We're generating standard 1 gram tokens. We converted the lowercase. We're lemmatizing. Right now, we're filtering parts of speech. So this may take a few minutes. After this, we're gonna remove the regular expressions. So you can see it still has a star here. So this it's a large data set, so this might take like a minute or so. Okay, so we finished that, and now we've removed elements according to the regular expressions. And then after doing all of this, we remove null documents and join the tokens into a single string. And you can see here, we only filtered out one tweet. And these are the tokenized ones. And after we've done all that processing, you can see like this tweet got changed to this. So you can see the Twitter handle got removed. Some of the, to and the, some of these stop words have been removed. Some of these stop words, also the plural have been lemmatized to singular, right? In some cases. Notice, so all these Twitter handles are gone, but we kept the hashtags, right? So Okay, so these have been fully processed and exported. So if you go to the data now, this is my original labeled data, and now I have labeled features. Right? I'm going to run one more. So what you're going to do after you run script 1 on the labeled data 6 times here in the step 2 processing menu, set all flags true. Okay. So then you're going to skip the pre-processing. You're going to skip one pre-processing step. Skip one pre-processing step at a time by setting each flag false. So let's say I want to do this fast. These ones are fast, but the filtering this one takes a long time. So let me do this one. I mean, you're gonna do all these, right? You'll set the remove stop words flag as false and keep all the other ones true, and then you'll run that script 1, and then you'll go back, turn this to true again, and then make the lowercase flag false, and then make the limitize flag false, and then the filter parts of speech flag false, and so on. So let me do one more. I'll do this filter POS flag. So for this one, I'll set it false. I'm gonna save, and I'm just gonna click here, restart the kernel, and rerun the whole notebook. So this will rerun everything. Just double check to make sure that you're running it on the labeled data, not the unlabeled. So it's running. So we'll see here when it hits the pre-processing. Running the script. Okay, so these have changed the numbers. So you can see we're removing stop words, generating 1 gram, converting lowercase, limitize tokens. Removing stop words. Again, okay, we're not filtering parts of speech, but we are removing elements according to regular expressions. And it's done now. So you can see it was exported to the data folder with this name, right? So if we go here to the data folder, now we have our original labeled data, we have labeled data with all the features, and we have labeled data features without filtering parts of speech. Right? So after you run this, you're going to run script 1 on this labeled data once with all the features, and then once skipping one feature at a time. Right? And that'll give you that'll create a total of 6 labeled feature files, right? And they'll be labeled feature, and then maybe some of them will have the without after it. Okay, so once you've created these 6 files, now we're going to move on to script 2, and we're going to train and test the SVM for each of those 6 feature files. So we'll move on to script 2. Okay, so here we're going to train and test the support vector network. We've got our libraries. These are our SVM machine learning libraries. You can see here in the data section, I've already saved these 6 file names for you, right? So this will be the first one, and then without the features, without the stop words, the features without removing stop words, without lowercase, without limitizing, without filtering POS, without removing regular expressions. So you're going to go through these one at a time and run script 2 on each of these files one at a time. We'll see here. So I'll go through this once just to show you what's in the script. So it's going to open up that. Now notice this is not labeled data, it's the labeled features, right? So this is the raw data. This is the full the features with running all 5 steps. So okay, so that's what it looks like. Going to verify that we have no empty tweets. All right. So here's like the first 5 we already have. Okay. So so we're going to train the SVM. So first of all, the fraction of the data that we're reserving for testing is 0.2. So we're going to train on 0.8 and test on 0.2 of the data set. You can just leave this one alone. Here for the minimum m-gram and the maximum n-gram, I'm going to set this as 1 and 1 for this exercise, right? And I mentioned this here when we're training and testing an SVM for the 6 feature files. Run the models with 1 n-gram features, which is min n equals 1, max n equals 1. So this will just treat each token. Our feature set will be the regular tokens, 1 gram features. And then if we run script 2 to the very end, it will generate a report, a classification report for the SVM, and it will save it. So let me go through this. So we'll save min n is 1, max n is 1. Now we're going to train the SVM. We're going to tokenize using bigrams. We're going to split the data into the training and testing sets, and then we're going to train the SVM classifier. So we're using a linear kernel. I'm going to measure the elapsed time, but you can see it's still going here. And this will usually take anywhere from 20 seconds to 5 minutes, right? Depending on mostly depending on your n-grams. If you're just using 1 n-gram, 1 gram, or 2 grams, or 3 grams, or whatever. So, and once it's finished, then we'll use the training set to test the SVM results. The test set, right? And we'll use the SVM classifier that we've created to predict the classes for the test set, right? And we'll save those as predictions, y predict, and then we'll classify the test set with the predictions here. So you can see here the X test and the Y test, right? So the X train and the Y train, this is the data. These are the features for the training and the test, and these are the results for the labels for the train and the test. So to test the SVM results, we train the classifier on X and Y trained to fit the classifier. And once we've trained it, then we're going to predict, we're going to use the X test set to create predictions, right? And then we're going to compare these Y predictions with the original Y test labels, right? And so this is the actual label, and this will be the predicted label. And that's how we can get the classification report. So this is still training. So this part will take some time. Sometimes it's faster than others. It also depends on your laptop. I think my laptop, because I'm running Zoom at the same time, is going to be a little bit slower. But usually, when Zoom wasn't on, this would go a lot faster. Okay, so I trained the SVM classifier. You can see it took 195 seconds. So it took a few minutes. Okay, so now I'm gonna use the classifier to make predictions on my test sets, and those are saved as Y prediction, and then I'll compare those to the actual labels in the Y test. And so you can see here with this SVM, when the label is 0, for the label 0, the precision and recall are 0.84, 0.74, with a combined F-score of 0.79, right? So label 1 is remember label 1 is class 1 is offensive and hate speech, right? So precision and recall are much higher for hate speech than they are for than for ordinary tweets, neither, right? So the overall accuracy is 90, or sorry, 0.9. So this is what I want you to report in the when you're evaluating the models. Its accuracy is 0.9 here. So again, you can make okay, so I'm just saving this as I'm going to export this report. Okay, so now I've created a report. Remember, this is run on labeled feature, not feature without filter parts of speech, just this labeled feature. And 1 is the minimum and maximum n-gram, right? So this is this includes all of the parameters, right? So this report will be saved in analysis. If you go to analysis here, you have the report for the labeled features, minimum max n-gram 1, and it's going to be the same report, right? It's the same report as up here, but you can just, I want you to be able to have this result later if you want to make graphs and stuff. So report of classification results for labeled feature, where the n-grams are just 1 gram. Training, 80% used for training, 20% used for testing, and here are the results, right? And so here's that 0.9 accuracy for that model. Okay, so if you go down further, there's one other step here, which is to apply the SVM to unlabeled tweets, to the Trump tweets. But if you run this, you'll see the report for analysis has been saved. We're planning to attempt the SVM to unlabeled tweets, but we haven't prepared the unlabeled data yet. So to apply this SVM to unlabeled tweets, we have to run script 1 on the unlabeled data using the same menu settings, right, as the labeled feature. So we'll do this later. So this is going to give us so we'll come back to this later. So in step B here, I want you to take these six different feature files, right? These labeled feature files, and then train an SVM for each of them. And using the report files and I want you to plot the accuracy score across the 6 different models, and then select the best set of features, right? So which of these 6 which of these 6 does the best, right? Is it best with all flags true, or is it better if you remove one of these, right? And how much does the accuracy go down if you remove, if you don't filter parts of speech, or if you don't remove regular expressions, or if you don't lematize, right? So you can use a bar chart, and just plot the accuracy score again, which is right here. So let me do one more for you since I already right, here's another one labeled feature without filtering parts of speech. So let me run that one just to compare. So if you don't filter parts of speech, does the classification accuracy go up or down? So to do this one, need to run it on this, right? So a labeled feature without filtering parts of speech. I'm just going to save this, make sure that my min n and max n are 1 and 1. Okay, and then I'm just going to rerun the whole thing. Here's it's going to take a while to do this. I'll pause and come back. All right, so finish that one. So this one took 175 seconds. Okay, so we've classified this. So check that out. The accuracy went up to 0.91, right? So it went up like 1% when we didn't filter parts of speech, which is interesting, right? Like you would think that doing all the pre-processing steps would result in a higher accuracy, but for Twitter text, maybe that's not the case, right? Maybe there's some parts of speech that we shouldn't remove. So, okay, so I've output the report here to analysis. So you go to analysis. So now you see that second report, right? Here's the original one, the features removing no steps. Here's the labeled features without filtering parts of speech, also one grams, right? So we look in here, same, we can compare the results. Right, so accuracy there is 0.91, and the accuracy for this one is 0.90, right? But you're going to run this script. You're going to run script 2 on each of these 6 feature files. You're going to get the accuracy scores from those reports, right? And do a bar chart showing the accuracy for those, right? And then you're going to select the best set of features for all future steps. So let's say, you know, we've only looked at the all flags true and the filtered parts of speech. You're going to do it for all 6 of these. But so far, this filtering, not filtering parts of speech flag is the best. So let's suppose this is the best one of all the 6. I'm not sure if that'll be the case, but let's just suppose it is. Then from step C moving on, we're going to just use that one. Right? We're just going to use that one where we filtered parts of speech, or where we didn't filter parts of speech. So now we're going to train and test an SVM for different n-gram configurations. So using that best set of features, which we decided was without filtering parts of speech, we're going to run script 2 on at least 3 different n-gram configurations. So the first one we already did, right? This is where min n equals 1 and max n equals 1. And that's just going to give us 1 grams, right? And that's, we already have that report here, right? This 1 gram. If you set min n to 2 and max n to 2, that will just give you 2 grams, right? If you set min n to 1 and max n to 2, that will give you 1 grams and also 2 grams. And you could even do like 3 grams or 4 grams. So what's a 1 gram or a 2 gram? So right now, let's see, a 1 gram is here, like each of these tokens, right, is a 1 gram. But if you do 2 grams, it will take this and this together as 1 token. And then it will take this and this as 1 token. And then this and this is 1 token. So 2 grams take 2 tokens as a pair. So if you set here, I'm going to do another one. I'll do this one as an example, right? But min n equals 2 and max n equals 2, and that will just give us 2 grams, right? And that way we can compare, again, we're going to compare the accuracies and see is 1 grams better or 2 grams better or 1 grams plus 2 grams, right? So you're going to do this analysis, at least 3 different n-gram configurations, all on your best feature file. Those reports will be saved, and then you're going to use the best set of features. Yeah, is plot the accuracy score across these different n-gram configurations, and make a bar chart showing that. Okay, so that will be here in model. Sorry, in script 2. We're going to stay with this file because that's so far the best set of features of the 2 we compared. But I'm going to go down to here. To look at 2 grams, I need to set these both to 2. So I do that, and I'm going to run it. Did we do it? Okay. So we're testing the classifier, or we're creating a classifier. Okay, training the classifier. I'll pause. Okay, that took some time, but again, I think this takes longer on my computer right now because I'm running Zoom at the same time. It might be faster on yours. Okay, so so this is interesting, right? The accuracy of 2 grams alone, 2 grams is 0.8, right? Whereas the accuracy with 1 gram was 0.91. So this has also been saved. Right, here, report labeled feature without filter parts of speech, 2.2. So if you go to the analysis folder, right, so now we've got the report SVM on labeled features without filtering parts of speech with 1 gram, only 1 gram, and only 2 grams, right? So for me, yeah, so I got 0.91 for the 1 gram and 0.8 accuracy for the 2 grams. Okay. So you're gonna, assuming this is your best model or best feature set, the labeled feature without filtering parts of speech, you would do this 1 more time at least, right? With minimum and min n is 1 and max n is 2, and that would give you both 1 gram and 2 grams. So you can try some other n-gram configurations if you want. For example, you could do, min n equals grams, or you could try, 1, 3. This would be 1 grams plus 2 grams plus 3 grams, right? So you can try different configurations if you want. I'm only asking you to try these 3. Again, using whatever your best set of features are. And then plot the accuracy scores for these 3 different configurations. So that's another bar chart with at least three bars, right? Okay, and once you've done that, then I want you to choose your best classifier. So your best classifier is going to be the one that has the best set of features and the best set of n-grams. So for right now, of the ones that I've done, it's the labeled features without filtering parts of speech, 1 grams, right? So for now, this is my best model. you might find a better one. Um, but I want you to select the best n-gram configuration. So, and then examine the various metrics of your best classifier. So the recall, precision, and accuracy. So now we're going to look at this one in particular. Okay? So what is the, compare the precision and recall for the 0 class and the 1 class. Notice that the precision and recall are much lower for the 0 class tweets than they are for the 1 class tweets. And just take note of these measures, and you can include those in your report. I don't need you to report on the precision, recall, and F1 score or the accuracy for all the other models that you do. I just want you to report these metrics for your best model, your best classifier. So steps A, B, and C are to kind of go through this feature space and go through the n-gram space to find the best classifier that you can. Okay, and once you've done that, now I want you to move on to the unlabeled data, right? We're gonna this unlabeled data of Trump's tweets. I want you to take your best classifier, and in steps D and E, we're gonna run that best classifier on the Trump tweets and classify those tweets. But first, before you do that, you have to go back to script 1, and we have to run script 1 on the unlabeled data. So let me just show you again what we're just show you exactly what we're doing here, why we're doing this step. Right. So we've used the label data, we've used the training set and the test set. We did 80-20, not 70-30, but we've created, at least 6 classifiers and then pick the best of those and then do 3 classifiers by n-grams. So we've evaluated our classifier based on this test set, right? And we've identified the best classifier. Now what we're doing, we've trained it and we have this classifier, but now we want to do prediction on the Trump tweets, right? These are not labeled. So, but still we can't run the classifier on the raw data. We still have to extract the features, right, before we can, right, we're going to run the classifier on the features of the Trump data set. So, but the question is which, so we go back to script 1, right? Now we're going to do in data, right? Instead of label data, we're going to switch this. Finally, we're going to run this on unlabeled data. But before we do this, right, we need to set the menu flags to our best set of features. So which of these models was the best? Right? Was it all flags true, or was it one of these flags false? So of the ones that I looked at, this one is the best, right? This setting the filter parts of speech flag false was the best one of the 2 that I looked at. So for me, I'm going to go back down to my menu. Sorry, there are several like functions and things in here you have to go down to past. So let's go past the functions, back down to, so step 1, tokenization menu, and step 2, the pre-processing menu. So here, right, I want to, the tokens have to be the same. So I have to pre-process the unlabeled data in the same way that I'm going to pre-process the label data to create the SVM model, right? So in this case, I want true, 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 and a false for the filtering parts of speech flag. And then everything else will be the same. So those are the 2 parameters I have to change. I have to make sure I'm running this on unlabeled data and choose the right combination of flags. Okay, so I'm gonna save this and run it. Right, and this is step D, right? So I'm running script 1 on my unlabeled data using the menu flags for my best set of features. And this is going to create one unlabeled feature file in my data. So let's make sure this gets done. So it's going to preprocess token. It's going to apply the menu here in a second. Okay, it's removing stop words. Now this is going to take a little bit longer to preprocess the unlabeled tweets because the Trump data set has, I think the original data set that we're training on has like something like 20,000 tweets. This one has like 50,000 or more. So it might take a little bit longer to preprocess those tokens. So we're lemmatizing those 50,000 Trump tweets. Actually, this file name is not just preprocessed labeled tweets. I'm preprocessing labeled and unlabeled tweets, but still, yeah, maybe I'll just change it to preprocessed tweets. Okay, so I'm lemmatizing tokens. Remember here, I'm not filtering parts of speech for this particular one. And now I'm removing elements, regular expressions. Okay, so here, these were the original tokenized tweets. Be sure to tune in, right? And after they're lemmatized and lowercase and all that, sure tune watch Donald Trump, right? So these are the processed tweets. And those have been saved to the data folder. Right, so here's all my labeled data, labeled features without filtering POS. Now here's my unlabeled data, my unlabeled features without filtering POS. So when I go back to script 2, right, in this final step, I'm going to retrain my best SVM model. I'm going to and apply it to the appropriate unlabeled feature file. So I'm going to train it on this one. Oops, sorry, I don't know. I'm going to train the SVM on this labeled feature without filtering POS, and then I'm going to apply that SVM to the unlabeled feature without filtered POS. All right, so let's do that. Go back to script 2. So go up to the top here, and we just need to make sure that we're, now again, I'm using this one because that's the one that gave me the best accuracy. If you find a different one, gives you better accuracy, then that's what you'll run it on. Next, we have to go down to the n-gram parameters. Now remember in this step, I found that 1 grams were better than 2 grams. I didn't run this one, you'll run this one, but of these two, the 1 grams did better. So I'm gonna choose that model, right? Because that's my best SVM, my best n-gram configuration. So you can set those back to 1. Okay, so that's all I have to set. Make sure these are appropriate. The best n-gram configuration on the best feature file. I'm gonna run those. All right. So it's gonna take some time again to train the classifier. Should reboot this in just a second. So let's see when it gets down here. All right, so we're training it, and I'll put it on pause here because it's probably gonna take a few minutes. All right, so we retrained classifier. This is our best classifier so far. And again, right there, it has that same 0.91 accuracy. The difference is because we had trained this unlabeled feature without filter POS that matches this file. Now at the bottom, in step 3, applying the SVM to unlabeled tweets, it actually ran this code. And it's actually still running it now. You can see we're applying the SVM to the unlabeled Trump tweets now. So it's attempting to apply the SVM to the unlabeled tweets, and it's going to label the Trump tweets. Remember, there are like 50,000 of these, so it's going to take a second. And the critical line in here, right? This is reading in the new data, where it's just adding a UN right in front of the original file name, right? Here's the labeled tweet without filter POS. This is unlabeled tweet without filter POS. So it's opening that, and then we have to vectorize it using the same vectorizer that we used above. And then once the new tweets have been vectorized, we're going to use the SVM classifier to predict those new tweets. And the new classes, the predicted classes of that unlabeled data will be here. And then I'm going to save that into the pandas data frame. So, and that's going to write over the old class with the had like class XXXXX. Now they're going to be written over with actual predictions of 0 or 1. So it's still running that. So I'll pause. Okay, so it finished applying the SVM classifier to the unlabeled tweets. The predictions have been saved. The predictions for this data set have been saved in the analysis, and they are labeled. It's just this data file name with the prefix of predictions in front of it. Oh, and also the 1 or the min and max n-grams. So, and then that data set looks like this. It has the tweet, right, with the tweet, and then the predicted class of 0 for non-offensive, non-hate speech, and a predicted class of 1 if it's offensive or hate speech. And you can see of those 55,000 tweets, it predicted 50,000 of them are not offensive, and maybe 6,500 are in that offensive or hate speech category. So that's the end of the script, right? Once you've done this, you've retrained your best SVM model, you've applied it to your unlabeled feature file, you've saved the predictions. The last thing I want you to do with this, right, before you report your findings, is go and examine the 0 and 1 class predictions, right, in this file. And I want you to select some sample tweets of the Trump tweets, right, which you think are appropriately predicted, and some which you think are not appropriately predicted or correct. So I can show you the predictions are here in analysis. So, right, we have the report. So this is the report labeled feature without filtered POS, the 1 gram. This is our best model. But here are the actual predictions. You click on that. So here's the predicted class, and here's the tweet. Actually, this is the tokenized. These are the tokenized features. So I think I'm going to try to change the code so that you can actually not just see the tokens, but the original tweet. So I'll fix that so you can see the original tweet. But let's, if you filter this, Now you can filter, on 0 or 1 class. So let's just look for 0 for now. So these are predicted as not being offensive or hate speech. And what I want you to do is find an example, pick any tweet here that you think is accurately classified, right? So, Donald Trump read top 10 financial tip, late show David Letterman. That seems, funny. That seems like not offensive. So that's a good example of a correct classification. Now go through here and look for predicted class 0. Do you find any offensive ones? Right. So, maybe, I don't know, you may not find any, but kind of look through and see if you find any that might have been, maybe should have been classified as offensive. So you can look through, and if you find any, so far these all look like pretty. So you may not find, it may not be easy to find an offensive one. Okay, so, but you can look, right? And then, but the more controversial ones or the difficult ones are going to be class 1. So these are class 1 are tweets that were predicted to be offensive or hate speech. To be honest, as maybe offensive as some of Trump's tweets are, I don't think many of them rise to the level of hate speech, but maybe offensive. So, but I think you'll see here, looking through these, a lot of these do not appear to be that offensive, right? Even though they're classified that way, right? So Trump International Tower, Chicago, ranked 6th tallest building in the world. Doesn't strike me as offensive. So to be honest, a lot of these seem not to be that offensive, right? So, but I want you to find, some that are offensive, or at least, if not offensive, at least kind of controversial, or I would say contentious, right? So must stand firm, employ sabotage Israel, selling gun Mexican drug dealers. Oh, to be honest, like the older these tweets get, some of the more kind of contentious they get. So, right, extremely credible source called Office. They had told accidental foreign student. Extremely credible source called Office told birth certificate fraud. Right, so we're talking about Obama's like birth certificate, probably letting China know advance. Even cheating can't beat you, right? So some of these they're not, I wouldn't say they're super offensive, but they're definitely promoting ugly, inefficient, unreliable, bird-killing, noisy neighborhood, destroying material, big mistake. But they're not super offensive, most of them, but they are more contentious in the most cases. And again, these are ordered by time right now. So the more like, the further you go, like in his presidency, the more kind of contentious he became, right? Never big fan Bush, who gave you Obama. Right. So find some of these that you do think are more contentious, and then maybe some that are not really contentious, right? Okay, and then we're going to report your findings. So in the report, I want you to analyze your findings and report between 1,000 and 1,500 words, and use these following headers to write your report. So introduction, be brief and concise. One header on effective features on classification accuracy. So this is where you're going to talk about step B, right? And show that the bar chart you created in step B, or those 6 feature sets, right? Then the next will be the effective n-grams. So analyze the SVMs you trained in the 3 or more n-gram configurations, include the bar chart you created in step C. Then lastly, right, and then summarize the accuracy, or let's see, evaluate your best SVM classifier. So this is at the end of step C, right? I ask you to look at the metric. So, for this one, the labeled feature without filtering POS, 1 gram, that was our best one of the ones that we did. So, tell me about the precision, the recall. Like you can report this table, right? But write me a few sentences about like, what does this mean? If the precision is 0.84, what does that mean? Or the recall is 0.74, like interpret that for me in terms of, if a tweet's offensive, what's the likelihood I don't classify it as offensive? Or if a tweet's not offensive, what's the likelihood I do classify it as offensive, etc. So just kind of here, take some time, take a paragraph, right, to evaluate your best SVM classifier and really dig into these recall, precision, and accuracy measures and give me some kind of hypothetical examples of what those numbers mean. So that's the first, steps A, B, and C, right? And then for steps D and E, where you apply the classifier to Trump's tweets, tell me, are Trump's tweets hateful or offensive? Summarize your analysis of the prediction of Trump's tweets. Cite at least 4 examples of Trump's tweets which fill the cells with the confusion matrix. And remember that confusion matrix is this, right? So offensive tweets which were predicted offensive, offensive tweets which are not predicted as offensive, which were predicted to be not offensive, right? Non-offensive tweets which were said to be offensive, and non-offensive tweets which were correctly classified as not offensive. So try to find examples of each of these. Like, to be honest, I was pretty surprised that the classification using this classifier to classify Trump's tweets did not seem all that great to me. Right? I mean, it did identify like some more contentious tweets, but there seemed to be a lot of non-offensive tweets which got classified as offensive. Right? So, in your conclusion, tell me your impressions of your classifiers and the more general strengths and weaknesses of the machine learning classification of hateful and offensive speech. If the classifier you think didn't work that well, give me some ideas about why. Why do you think it didn't work so well? Is it about the nature of hateful and offensive, the ambiguous nature of hateful and offensive speech? Is it, is the data set that we use for training and testing different than the data that we're applying it to, the Trump tweets? Is that the appropriate classifier? Was it trained on the right data? Like, why might classification of Trump's tweets not been as effective as we hoped or as we thought? So yeah, this is the report, and I think yep, that's it. So let me know if you have any questions. I'll be happy to if you run into any issues with coding or anything, let me know, and we'll try to get you squared up. So make it fit into phases, yes. So yeah, that's all. And I look forward to reading your reports, seeing your classifiers and finding what's the best classifier that you come up with.